I have a dream that one day
Hi guys, welcome to this lesson on GPs. In this lesson, we want to look at word sums relating to GPs. In the first part of this example, which deals with word sums for GPs, it says the sum of the first three terms of a geometric series is 28 and the product of the first three terms is 512. Determine the common ratio and the first term. So let's look at the solution to this question or problem. We're going to convert the information given into equations. The first bit of information says the sum of the first three terms of a geometric series is 28. So we can write that S sub 3 equals 28. Now we use a sum formula. So the sum formula to write this whole equation in terms of A and R. So A into R to the n, so R cubed minus 1 all over R minus 1. So over R minus 1, this must equal 28. Now we're going to simplify this equation. R cubed minus 1 is a difference of cubes. And just a reminder that A cubed minus B cubed, when we factorize it, will be A minus B. In other words, a cube root of the first term minus a cube root of the second term. So this goes into the first set of brackets. Then A times A squared will give A cubed. And negative B times positive B squared will give negative B cubed. Then the middle term in the second set of brackets will be the product of the terms in the first set of brackets. So AB. And then with opposite sign, so with a plus. So we can apply the difference of cubes to R cubed minus 1. It's going to be R minus 1 into R squared plus R. So R times 1 is R, and then the opposite sign here. And then minus 1 times plus 1 will give minus 1 here. This is all over R minus 1. So over R minus 1. Then these factors will cancel. And of course, this is equal to 28. So we're left with A into R squared plus R plus 1 equals 28. Now, we are going to call this equation equation 1. Let's go to the second bit of information. It also says the product of the first three terms is 512. So it means term 1 times term 2 times term 3 is equal to 512. Now we can write these three terms in terms of A and R as well. T1 is the first term, that's A. The second term is AR. And the third term is AR squared, and this is 512. A times A is A cubed, and R times R squared is R cubed. We can use the laws of exponents and write the left-hand side as AR all cubed. And we can solve for AR by taking the cube root on the right-hand side. So AR will be the cube root of 512. And on a calculator, this comes to 8. Now we can write A in terms of R. So A will equal 8 over R, and we can call this equation 2. We want to solve these two equations simultaneously because the question says determine the common ratio, which is R, and the first term, which is A. So we're going to substitute equation 2. So substitute equation 2 into equation 1. So we have A, which is 8 over R. So 8 over R into R squared plus R plus 1. And this must equal 28. We can get rid of the fraction here by multiplying through by R. And on the right hand side, we're going to get 28R. We can multiply the 8 into the brackets. Now we can bring everything to the left-hand side. So 8R minus 28R is minus 20R. And this equals 0. We can simplify this quadratic by dividing through by 4. Now we can factorize. And we solve for R. We see that R is equal to a half, or R is equal to 2. Now that we have the values of R, or the possible values of R, we can substitute it back into equation 2 and get A. So when R is equal to a half, using this equation, A equals 8 over R. So A will equal 8 over a half. And this, of course, is 16. Then when R is equal to 2, then A will equal 8 divided by 2, which is 4. In the second question here, it says 3 positive numbers are in the ratio 1:3:7. If 12 is added to the largest number, the 3 numbers form a GP. Find the numbers. So we have 3 numbers, and we can let the first one be x. So then our numbers will be, the first one we can make equal to x. Then the second one will be 3x, because these numbers are in the ratio 1:3:7. So the second number is 3 times the first number. And the third number is 7 times the first number. So these are our 3 numbers. Now it says if 12 is added to the largest number, the 3 numbers form a GP. So then our GP will be x, 3x, and 7x plus 12. Now we can use the fundamental property of GPs, and we know that it says term 3 divided by term 2 is the same as term 2 divided by term 1. So applying this property, term 3 divided by term 2 must equal term 2 divided by term 1. And on the right hand side here, the x's will cancel. So we're left with 7x plus 12 over 3x equals 3 over 1. So we can cross multiply. 3x times 3 is 9x. And 7x plus 12 times 1 is 7x plus 12. We can bring all the x's to the left-hand side. So 9x minus 7x is 2x. And we see that x is equal to 6. Now it said, find the three numbers. So we've got the first number x, the second number will be 3x, and the third number will be 7x. So our numbers then will be x, then 3x, so 3 times 6, and then 7x, 7 times 6. So it will be 6, 18, and 42. So let's look at your answers to this question. In the first one it says the sum to n terms of a geometric series is 341. So let's write that down. S sub n is 341. Then it also says the first term is 1. So a is equal to 1. And then the last term is 256. We must find the common ratio r. So the last term is t sub n, and this is 256. We can take s sub n and write this equation entirely in terms of a and r using the sum formula. So a into r to the n minus 1 all over r minus 1 must equal 341. But we do have the value of a. So then we can plug in a equal to 1 here. So we end up with r to the n minus 1 over r minus 1 is 341. This we can call equation 1. We also want to convert this equation and write it entirely in terms of a and r. And we can use the formula for the nth term. So t sub n is ar to the n minus 1, which is 256. A is 1, so hence r to the n minus 1 equals 256. Now I'm going to rewrite the left-hand side of this equation slightly differently. I'm going to use the rules of exponents and write it as r to the n times r to the negative 1. I'm going to take r to the negative 1 into the denominator. So the power becomes positive. So it's r to the positive 1. This is 256. And now I can get r to the n in terms of r. Multiplying both sides of this equation by r, we see that r to the n is 256 times r. This I'm going to call equation 2. So equation 2. Now we're going to substitute equation 2 into equation 1. So r to the n we can replace by 256r. So 256 times r minus 1 over r minus 1, and this is 341. We're going to cross multiply or we could multiply both sides of this equation by r minus 1 to get rid of this fraction here. So 256r minus 1 equals 341 into r minus 1. And we can multiply out the right-hand side, so it's 341r minus 341. And we're going to bring all the terms in r to the left-hand side. So it's going to be 256r less 341r equals minus 341. And the negative 1 I'm going to take across to the right-hand side, so plus 1. Then let's see what the left-hand side comes to. So 256 less 341, and it's negative 85. So the left-hand side is negative 85r. The right-hand side is negative 340. And in solving for r, let's see what that comes to. So negative 340 divided by negative 85. And we see that r equals 4. In the second question here it says the first term of a GP is 3 and the ratio of the seventh term to the third term is 4:3. Calculate the ninth term. So let's start by writing down what we are given. We are told that the first term is 3 and the ratio of the seventh to the third term is 4:3. So the seventh to the third term is 4:3. And we need to find the value of the ninth term. Now we're going to convert this ratio into a fraction. So T7 over T3 must equal 4/3. Then using the formula for the nth term, T7 is AR to the sixth and T3 is AR squared. Here the a's cancel and we have r to the sixth divided by r squared, which is r to the 4, and this is 4/3. Now we need to find the ninth term. So T sub 9 is AR to the 8. And of course we do have A. A is equal to 3. So A is 3. Now we have r to the 4 here. So I'm going to rewrite r to the 8 as follows. It's going to be r to the 4 all squared using the rules of exponents. And now we replace r to the 4 with 4/3. So 4/3 all squared. And this is 3 times 16/9. And of course 3 goes into 9 thrice. So we end up with 16/3. In number 3 it says the first two terms of an AP, A, and a GP, B, are the same. So we are given the sequences for both the AP and the GP, and we can see that in both cases the first two terms are -2 and x respectively. In A we have to write down the third term of the GP in terms of x. Now to find the third term of the GP we need a common ratio r. And we can get it by taking term 2 divided by term 1. So then for the GP, the common ratio r is term 2, which is x, over term 1, which is -2. And this of course is -x/2. And now we can get the third term by taking the second term, which is x, and multiplying it with a common ratio. So this comes to negative x squared over 2. So we've answered A. We had to write down the third term of the GP in terms of x. Now, in the second part, in B, it says if the sum of the first 3 terms of the AP is equal to the third term of the GP, determine x. We only have the first 2 terms of the AP, but we want the sum of the first 3 terms. So we want to find the value of the third term in terms of x as well. In order to do that, we need a common difference, and then we need to add the common difference to the second term x. So let's first find the common difference. So for the AP, the common difference D is a second term x less the first term. So it's x less negative 2, and this is x plus 2. So now we can write down the third term by adding the common difference to the second term. So term 3 then will be the second term, in other words x, plus the common difference. And this comes to 2x plus 2. Now it says the sum of the first 3 terms of the AP. So we want S sub 3. It's going to be the first term. So negative 2, the first term, plus a second term, which is x, plus a third term, which is 2x plus 2. So this comes to 3x, because these terms cancel. Now, the sum of the first 3 terms of the AP is equal to the third term of the GP. We already have the third term of the GP from part A of the question. So that means that 3x must equal negative x squared over 2. And we need to solve for x in this equation. We can multiply through by 2 to get rid of the fraction here. So 6x equals negative x squared. We can bring all our terms to one side. And here we can take out x as a common factor. And hence x will equal 0, or x will equal negative 6.